Hello everyone. In today's session, we are going to learn about a complete guide about HashiCorp software products. So what is HashiCorp? HashiCorp is a software company that provides tools for provisioning, securing, running, and connecting cloud computing infrastructure. HashiCorp's products are used by developers, operators, as well as security professionals. HashiCorp was founded in 2012 by Mitchell and Armand. So the first product was Vagrant, which allows developers to create and manage development environments using virtual machines. The HashiCorp Cloud Platform is a fully managed platform that offers HashiCorp products as a service. HCP HashiCorp Cloud Platform allows organizations to run HashiCorp products as managed services across providers like AWS and Azure. So HashiCorp Cloud Platform offers production-grade infrastructure, built-in security, and pays-as-you-go pricing, push-button deployment, fully managed upgrades, and backups. So why we should use HashiCorp products? So HashiCorp products offer a holistic solution for modern IT challenges. They provide consistency, security, and scalability in infrastructure management, enabling DevOps team to deploy, secure, and scale applications seamlessly across multi-cloud environments. HashiCorp tools are essential for achieving agile, efficient, and reliable IT operations. What are the products offered by HashiCorp? For infrastructure, Terraform and Packer is used. For security, Vault and Boundary is used. And for networking, Consul is used. And for applications, Nomad, Waypoint, and Vagrant are used. So this is the application delivery lifecycle of HashiCorp. And how are the products used in the application lifecycle? So first one, as you can see, right. So every application needs to return and modify, regardless of language, framework, or OS. So for writing, we can use Vagrant HashiCorp product. So it is basically a command line utility that isolates dependencies and the configuration within a single disposable and consistent environment. Next is testing. So every application should be tested with various levels of granularity from unit to integration to acceptance testing. After testing, we need to configure the source code. So for this, we can use Packer to so the source code and configuration management are transferred into a compiled artifact suitable for product environment. So this can be a static binary jar file or deb package, Docker container or VM image. Next is provision. So application require infrastructure to run on. This can be through on-premises data center or through the cloud that involves low-level storage, compute, and networking provided by infrastructure as a service provider. So could be a higher level service abstraction provided by as platform as service, or it could involve multiple providers. Next is deployment. So this process of mapping artifacts to underlying infrastructure is deployment. This step can be tightly coupled with provisioning if applications are back- baked into machine images, but typically it is a distinct step which is done more often with provisioning. Next is to connect and monitor. To connect and monitor, we can use Consul HashiCorp product. So once an application is deployed, the focus shifts to keeping that application running. So reliability engineering practitioners use monitoring tools and techniques such as logging, application performance management, request tracing, and more to maintain deep visibility into the health of the application. Next, we will learn about what is HashiCorp Terraform. So Terraform is an open source cloud agnostic tool that helps users to build, change, and version infrastructure. It's used primarily for DevOps team to automate infrastructure tasks such as provisioning and resources. Terraform was created by HashiCorp in 2014. It's written in the Go language. Users define and provide data center infrastructure using a declarative configuration language known as HashiCorp configuration language or optionally JSON. So what is Go or Golang programming language? So Go is also called as Golang or Golang language. So it is an open source programming language that Google has developed. Software developers use Go in an array of operating system and frameworks to develop web application, cloud and networking services, and other types of software. What is Terraform? So Terraform is a tool used to implement infrastructure as code. Using Terraform, we can automate the infrastructure in the cloud. So it is an open source tool, but it has an enterprise version and it supports almost all cloud infra providers like AWS, Microsoft Azure, IBM Cloud, and Google Cloud, DigitalOcean, etc., and physical infra providers. So what is infra as code? So infrastructure as code codifies and manages underlying IT infrastructure as software. Traditionally, managing IT infrastructure was a manual and difficult process. The person had to physically install and configure server. So it was expensive and slow and inconsistent. So infrastructure as code enables the devs or operation team to automatically install and configure and manage infra. So what is infrastructure provision? It's the automated process of setting up and configuring IT resources such as server, network, and storage to support application and services. This ensures rapid, consistent, and scalable resource deployment, reducing manual effort and error. Infrastructure provisioning allows for easy scaling of resources, ensuring that you can quickly adapt to changing demands while optimizing resource utilization for cost efficiency. So why we should use Terraform for infrastructure provisioning? So as Terraform is multi-cloud, provision resources across different cloud providers. Terraform is declarative. Describe what you want. Terraform handles how. Code reusability, modular configuration for efficient development, and Terraform support communities, vast community and extensive provider ecosystem. So how does Terraform work? So Terraform uses two input sources, the user-defined configuration and the data feeds about the current infrastructure setup. Firstly, Terraform creates a blueprint of the desired infrastructure setup. Second, Terraform evaluates the current state against the desired configuration. Next, Terraform proposes a plan to add or remove infrastructure component as needed. Further, provisioning. Terraform takes care of provisioning or any resources if you choose to apply the plan. Terraform can work with virtually any platform or service with an accessible application interface. It can deploy apps across several clouds quickly and consistently. Terraform eliminates the need to use cloud provider specific deployment. The uses of Terraform. Terraform can be used in three ways for creating the infrastructure, managing the existing infrastructure, and replicating the infrastructure. So, managing the existing infrastructure. So it involves importing resource state, creating corresponding configuration file, and using Terraform command to apply changes, allowing for infrastructure as code benefit in an existing environment. So, why there is need for import? So, Terraform is an infrastructure tool that lets to manage your infrastructure, regardless of where it is hosted and how it is deployed, manually deployed, or other infrastructure tools like ARM templates. So in case of Azure, you might run into a scenario where the existing infrastructure is already deployed. and your team or organization has decided to use Terraform for managing the infrastructure going forward. In such scenario, you need to bring existing infrastructure under Terraform's controls. So the steps for importing the deployed infrastructure. So identify the resources that you want to import to Terraform. Write the configuration for deployed resource. Run the Terraform import to import the changes to a state file. Then run Terraform plan to review the changes between the Terraform configuration and actual state. So it will make the changes in configuration to include the missing changes. After that, we will run the Terraform plan again to make sure that configuration includes all the attributes from deployed infrastructure. Another example is im- we can import an existing AWS S3 bucket into Terraform and manage its configuration and access policies through code and Terraform command, ensuring consistent management and automation. The second usage is replicating the infrastructure. So it involves defining new resources in code to match the desired state, ensuring reproducibility and scalability. Example, when you want to replicate the development setup also for staging or production environment. Next, we will learn about Terraform architecture. So Terraform architecture mainly consists of the following Terraform core, Terraform core, providers, and the state file. The Terraform core is also known as Terraform CLI. It's built on a statically compiled binary that's developed using the Go programming language. This binary is what generates the command line tool known as Terraform, which serves as the primary interface for Terraform user. Now providers. Terraform providers are modules that enables Terraform to communicate with a diverse range of services and resources, including but not limited to cloud provided databases and DNS services. So state file. The state file is an essential aspect of Terraform functionality. It is a JSON file that stores information about the resources that Terraform manages, as well as their current state and dependency. So Terraform utilizes the state file to determine the changes that need to be made to infrastructure when a new configuration is applied. It also ensures that resources are not unnecessarily recreated across multiple runs of Terraform. So these are the Terraform commands: refresh, plan, apply, and destroy. So initialize command is to set up the project. Download provider and initialize the working directory. Plan command is to generate an execution plan to preview changes before apply. And apply command is used to modify resources as per the plan, bringing the infrastructure to the desired state. And the destroy command is safely decommission and remove resources when they are no longer needed. Next, we will learn about what is the difference between Terraform and Ansible. So Terraform is used for initial provision and configuration of infrastructure, while Ansible is used to install and final deployment of application. Terraform is declarative, where Ansible is procedural or imperative. Terraform is perfect for configuring cloud infrastructure, while Ansible is perfect for traditional automation. Using Terraform, we can deploy resources like VPCs, load balancer, EC2 instance, etc. Using Ansible, one can deploy apps at the top of the infrastructure. So what's the difference between declarative and imperative? So declarative describes the desired end state of the system or resource. On the other hand, imperative specifies a sequence of steps or tasks to achieve the desired state. Declarative focus on what the system should look like, while imperative focus on how to get the system to the desired state. Declarative tools like tools are like Terraform Kubernetes for resource provisioning and SQL for database queries. On the other hand, Ansible uses tools like imperative tools are like Ansible, shell script, and procedural programming language. Declarative configuration are typically idempotent, meaning that you can apply them repeatedly without causing issues. And on the other hand, imperative configuration may not be inherently idempotent, and idempotence must be carefully considered and implemented. Terraform language. So Terraform uses the HashiCorp configuration language, which is a user-friendly declarative language used in Terraform. Its syntax is designed for readability, making it easy to define infrastructure resources and their relationship. It simplifies complex infrastructure provisioning, enhancing collaboration and maintenance. Next product is HashiCorp Packer. So Packer is an open source tool made by HashiCorp. It automates the process of creating virtual machine images on the cloud and on-prem virtualized environment. Packer uses a single JSON configuration file to create identical machine images for multiple platforms. So Packer can be used to create virtual machine images on the cloud and on-premise virtualized environment. It can also create identical machine images for multiple platforms. Custom images can also be created in Windows or Linux, and it will Packer can create Azure ARM templates as well. The benefits of using Packer. So as Packer is fast infrastructure used for fast infrastructure deployment, Packer images allow users to launch, provision, and configure machines in seconds. It is used for the greater stability. Users can use quickly launch and test machine images to verify that they are working. Packer can also be used for Terraform interoperability. Packer can be used for Terraform interoperability, so it users can standardize image workflows across cloud providers. It can also be used for VM creation automation. So Packer creates consistent images for multiple platforms in parallel. It can be also used for improving the stability. Packer installs and configures all software for a machine at the time the image is built. So what are the key terminologies for Packer? Artifact, builds, and builders. So artifacts are the results of a single build and are usually a set of IDs or files to represent a machine image, while builds is a single task that eventually produces an image for a single platform. Multiple builds can run in parallel. The example usage is sentence. In a sentence, the Packer build produced an AMI to run our web application, or Packer is running to build now for VMware, AWS, and Virtual. Next is builder. So these are the components of Packer that are able to create a machine image for single platform. Example builders include VirtualBox, VMware, and Amazon EC2. Builders can be created and added to Packer in the form of plugins. Next is provisioner. So these are the components of Packer that install and configure software within a running machine prior to that machine being turned into a static image. So templates are JSON files which define one or more builds by configuring the various components of Packer. Next, we will see the difference between Packer and Docker. So Packer is used for image creation and provision. On the other hand, Docker is used for containerization and runtime. Packer is used to build machine images, while Docker runs lightweight containers. Packer is used for VMs and cloud images, while Docker is used for application deployment. Packer configuration is in JSON or HCL, and Docker configuration is in Dockerfile. Packer supports various cloud providers, while Docker is platform independent. Packer uses pre-built images for deployment. On the other hand, Docker build and run the application. Packer uses infrastructure as code, while Docker application isolation is used for application isolation and scaling. Next is HashiCorp Vault. So HashiCorp Vault is a security-focused tool that provides a centralized and secure solution for managing secrets such as passwords, API keys, and encryption keys. It offers features like dynamic secrets, access control, and encryption services to protect sensitive data. What ensures secrets are stored and accessed securely with audit trails for compliance. It's a crucial component in modern IT environment for enhancing data security. So what are the benefits of HashiCorp Vault? So it is used for enhanced security, where it provides a centralized, secure and audited platform for storing and managing secrets, reducing the risk of security breaches. It also used for dynamic secrets, so it can generate short-lived dynamic secrets on demand, reducing the exposure of credential and enhancing security. It is also used for access control. The fine-grained access policies allow organizations to control who can access the secret, ensuring the least privileged access. It is also used for compliance and audit auditability. So what machine detailed audit log, making it easier to track and demonstrate compliance with security and data protection regulations. What is also used for integration, as it seamlessly integrates with a wide range of infrastructure and cloud platforms, enabling secure secret management in diverse environments. So this is the workflow for HashiCorp Vault. So first is the authentication. So authentication in Vault is the process by which a client supplies information that Vault uses to determine if they are who they say they are. Once the client is authenticated, such as auth method, a token is generated and associated to a policy. Next step is validation. So Vault validates the client against third-party trusted sources such as GitHub, AppRole, and more. Further, authorization. So a client is matched against the Vault security policy. So this policy is a set of rules defining which API endpoints a client has access to with its Vault token. Policies provide a declarative way to grant or forbid access to certain paths and operations in Vault. Next is access. So Vault grants access to secret keys and encryption capabilities by issuing a token based on policies associated with the client's identity. So the client can use the Vault token for future operations. So HashiCorp Vault has many use cases, including secret storage, which can store both static and dynamic secrets, as well as for data encryption, which can encrypt and decrypt data stored. It can also be used for identity-based access, as store and manage AWS access credentials. It is also used for key management, where it manages the key, and it also provides authentication for backend, password management to store and encrypt passwords. Next product is HashiCorp Boundary. So Boundary is an open source identity access management tool that secures user access to dynamic host and critical infrastructure. It's designed to simplify and secure least privileged access to cloud infrastructure. It provides secure remote access solution that allows access to applications and critical systems. It provides access without the need to distribute and manage credentials, configuring the firewall or expose the organization's private network. So what are the benefits of or the features of Vault? It can be used in a single sign-on to target services and applications via external identity props. So just-in-time network access to private resources. Next feature is to identity-based access control for users and applications. Session recording and audit logs. The boundary has two components. Controller, where it manages state for users, host and access policies. And for the external provider, SCP boundary can query for service discovery. So this is the workflow of the HashiCorp Boundary product. So first is authenticate. The user authentication. The user logs in with a trusted identity based on the rules and policies. With a trust identity platform such as Azure, Active Directory, Ping, or any other trust identity platform supporting the OpenID Connect. Next is the granular authorization. Boundary authenticates and authorizes users based on the rules and logical services and tightly controls access and actions performed against system. Next is the user select application or host from a catalog. So the user select the application or host from dynamic host catalog. Next, it will provide access. Boundary streamlines connection to host by automating discovery and access configuration as workloads are deployed or changed. Next product is HashiCorp Consul. The HashiCorp Consul is a service discovery and service mesh tool that enables efficient and secure communication between microservices in modern cloud native environment, offering features for service registration, health checking, and load balancing. It helps organizations maintain reliable and scalable applications by automating network configuration. It is an open source networking software that helps organizations to connect and secure distributed application and service. So it also built on Golang. So what are the features of the HashiCorp concept? So it is service discovery, service mesh, used for traffic management, used to automate updates to network infrastructure devices. It is used for identity-based service networking, network automation across multiple cloud and runtime environments, and used for sidecar proxies in a service mesh configuration to establish TLS connections. So how does the console work? Console provides a control plane that enables you to register, query, and secure services deployed across your network. The control plane is the part of the network infrastructure that maintains a central registry to track services and their respective IP addresses. It is a distributed system that runs on clusters of nodes such as physical layers, cloud instances, virtual machines, or containers. The control console interacts with the data plane through proxies. The data plane is the part of the network infrastructure that processes the data request. So next we will learn about the core console workflow consists of the following steps. So register, query, and secure. So register where teams add services to the console catalog, which is the central registry that lets services automatically discover each other without requiring a human operator to modify application code, deploy additional load balancer, or hardcore IP address. Next is the query. Console's identity-based DNS lets you find healthy services in the console catalog. So services registered with console provide health information, access points, and other data that can help you to control the flow of data through your network. Next, it will provide security. After the services locate upstream, console ensure that service-to-service communication is authenticated, authorized, and encrypted. So console service mesh secures microservice architecture with MTLS and can allow or restrict access based on service identities, regardless of difference in compute environments and runtime. The next product is HashiCorp Nomad. So HashiCorp Nomad is an open source utility that helps automate, schedule, and reschedule application deploy. It's a flexible workload orchestrator that can deploy and manage containerized application, non-containerized application, microservice application, as well as batch application. So Nomad can be used to manage cloud, on-premises, and edge environment. It is supported on Linux, Windows, as well as for Mac OS. So Nomad features are to reduce the complexity of automating, scheduling, and rescheduling application deploy. It is used for improving the total cost of ownership by providing better utilizing server hardware. It is used for deploying and managing containers as well as non-containerized application and virtual machine. So Vault identity-based security and boundary secure the remote access. So how Nomad compares to other tools? So Nomad differentiates from related tools by virtue of its simplicity, flexibility, and scalability and high performance. Nomad synergy and integration points with HashiCorp Terraform, Consul, and Vault make it uniquely suited for easy integration into an organization's existing workflows, minimizing the time to market for critical initiatives. So Nomad is an orchestrator. So what is an orchestrator? A program to coordinate and schedule complex computer system tasks across infrastructure. So it can manage the workloads that could be in containers, VMs, raw executables, jar files, and more. So orchestrator first became popular for large data analytics jobs that took too long to process if they weren't intelligently broken up and scheduled efficiently across an infrastructure. So as HashiCorp Nomad is an orchestrator that provides an efficient way to manage those tasks. Jobs don't necessarily need to be complex. You can use Nomad as your one tool to schedule all jobs, all your applications, and any task regardless of complexity level. So how Nomad compares to other tools? So the following are the characteristics generally differentiate Nomad from related products. As Nomad provides simplicity, it can be run in a single process with zero external dependency. Operators can easily provision, manage, and scale Nomad. So developer can easily define and run application. Nomad also provides flexibility, as it can run in a diverse workload of containerized, legacy, microservice, and batch application. So Nomad can schedule service, batch processing, and system job, and can run on both Linux as well as on Windows. It also provides scalability and used for high performance. Nomad can schedule thousands of containers per second, scale to thousands of nodes in a single clutch, and easily spread it across regions and cloud providers. It also provides HashiCorp interoperability, which elegantly integrates with Vault for secret management and Consul for service discovery and dynamic configuration. Nomad, Consul like architecture, and Terraform like job specification lower the barrier to entry for existing users of the HashiCorp stack. Next product is HashiCorp Waypoint. So HashiCorp Waypoint is an open source developer workflow that helps to simplify the process of deploying applications into infrastructure, as it allows developers to describe how to get the application from development to production in a single file. Next, it can also use to deploy using a single command, Waypoint. It is used for to define the application, to build, deploy, and release lifecycle as code. It can also use for the validation and debugging for any deployment using tools such as the Waypoint supports a number of build methods and target patterns out of the box, and it can be easily added via plugin. It can run from any laptop or continuous integration and continuous delivery too. So what are the advantages of Waypoint? So Waypoint is a server which is fully managed by HashiCorp. The platform provides a user interface integrated directly into the HashiCorp Cloud Platform portal. Waypoint can be used as infrastructure as code concept as it is simple and easy to use. You can integrate Waypoint with various code repositories like GitHub, GitLab, etc. The Waypoint UI provides an interactive interface to view the status of your builds. Platform teams can define golden patterns and workflow that enable application teams to build and maintain application at scale. So developers can stream logs from the application in real time, making it easier to diagnose issues. Vagrant uses an HCL-based configuration file to describe how to build, deploy, and release application to various cloud platforms. So defining workflows. So platform team can use Waypoint to define workflows that enable application team to build and maintain application at scale. To create new application, developers can use Waypoint to quickly create new application. Waypoint also used in managing application to manage the application at scale in any environment. So Waypoint basically uses an HCL-based configuration file to describe how to build and deploy and release application to various cloud platforms. Next product is HashiCorp Vagrant. So HashiCorp Vagrant is an open source tool that helps developers create and manage virtual machine environments. It's a command line utility that isolates dependencies and the configuration within a single, disposable, and consistent environment. The Vagrant can run on local virtual platforms such as VirtualBox or VMware. So the cloud via AWS or OpenStack, and it can also run on the containers such as Docker. So these are the uses of Vagrant. Vagrant can be used to build complete development environments. Vagrant as Vagrant can manage the lifecycle of virtual machine. Vagrant can also use for the lower development environment setup time. It increases production parity. Vagrant can use to create reproducible development environment. Vagrant can work on any project, and it can install every dependency that project needs. So why HashiCorp Vagrant? As Vagrant provides easy to configure, reproducible, and portable work environments built on top of industry standard technology and controlled by a single consistent workflow to help maximize the productivity and flexibility of you and our team. So what's the difference between Vagrant, Terraform, and Docker. So the purpose of the Vagrant is for local development and work, while on the other hand for Terraform is used for infrastructure provision and Docker is used for containerization of application. Next is for provisioning. So VMs or containers on the local system in Vagrant. While Terraform uses cloud and on-premises infrastructure, and Docker uses application container. Use cases for Vagrant. So it is idle for local development and testing. On the other hand, Terraform used for managing production infrastructure, and Docker is used for packaging and deploying applications. Vagrant uses configuration files and scripts, while Terraform employs declarative code for infrastructure. On the other hand, Docker defines containers with Docker files. Vagrant is limited scalability for local use, while Terraform scales effectively to manage complex infrastructure, and Docker is highly scalable for application deployment. Thank you.